Hi, I'm Michael Jessup, a Year 11 at Pakuranga College, and I'm entering my project I call the Pipe Express into the 2013 Brightsparks competition. The brief for creating this robot was to do with pipe networks. The idea is this: you have a complicated pipe network, and it's blocked. You don't know where the blockage is, and it's far too time consuming to take apart the whole network to find the blockage. That's where Pipe Express comes in. The idea is that you set Pipe Express at the start of your network, and then tell it to go. It will drive through your network, navigating through the maze of pipes, turning corners and such. When Pipe Express finds the blockage, it will shut down and start beeping. You then trace the sound of this beep to the relevant section of pipe, dismantle the pipe, remove Pipe Express, and fix the blockage. This means that you don't have to spend time trying to find out where the blockage is. Pipe Express does that automatically for you. It also means that you don't have to dismantle your whole pipe network. You just have to dismantle the relevant section of pipe that's blocked. This saves you a lot of time and money. This is the fully functioning prototype of Pipe Express. To gather information about its environment, it has 3 microswitches mounted at the front. To allow its human operators to control it, it has 3 toggle switches mounted at the back. To allow it to move, it has 2 small DC motors connected via gearbox to 2 large wheels. At the top here, it has a buzzer which alerts you to where your blockage is in your pipe. The whole thing is powered by a 6-volt lead-acid battery which is mounted at the bottom. I chose to mount it at the bottom to give it a very low center of gravity, making it extremely stable. At the heart of the robot is this, the PCB. The PCB is very compact, measuring 6.8 by 4.6 centimeters. I designed this PCB myself using dip-trace PCB modeling software and etched it myself using Pakuranga College's etching tanks. Instead of soldering all the components onto the PCB, which would have been very difficult in this small confined space, I instead chose to solder plugs onto the PCB and plug the components into the PCB. This is a very good system because I can remove the PCB from the robot at any time and troubleshoot it. The 3 main components on the PCB are the 2 ICs and the voltage regulator. The first IC is a PICAX 14M2 microchip. This acts as the brain of the robot, reading inputs and controlling outputs in relation to a predefined program that I wrote on my computer. I then download this program from my computer to the PICAX via a USB cable and a programming socket that I incorporated into the PCB. I actually went through 24 different programming stages to get to the final program that works well. The second IC is an H-bridge. This allows me to reverse the polarity of the motors, making the robot go forward and backward. This means that the robot is maneuverable enough to navigate through the pipe network. Also, by making one wheel go forward and the other turn backward, the robot can turn on its axes, which makes it very maneuverable. I designed Pipe Explorer's chassis on Google SketchUp and printed it using Pakuranga College's 3D printers. This allowed me to use very precise shapes, much more precise than if I were working with, say, wood or metal. For the wheels, I actually went through 6 different stages to arrive at a wheel that worked well. I'm just going to briefly explain what these 3 switches do. On these switches, up is off, down is on. If you're holding Pipe Explorer facing away from you, then the switch on your far right is the power switch. Turning this switch will turn Pipe Explorer on, like so. The middle switch controls the buzzer. When the switch is off, Pipe Explorer will only buzz during startup and when it encounters the blockage in your pipe. However, if you turn the switch on, Pipe Explorer will buzz every time one of the micro switches gets pressed, as well as during startup and when it encounters a blockage in your pipe. Most of the time you will want to keep this switch up, i.e. off, but you can play around with it. The switch on your far left is the reset switch. So when Pipe Explorer smashes into a blockage in your pipe, it won't do anything except buzz. So to stop it from buzzing, you flick the far right switch and it will appear to be off. You can then reposition Pipe Explorer and then turn the switch back off again, and Pipe Explorer will resume exploring your pipe while skipping startup processes. Let's have a look at my robot Pipe Explorer in action. I've made a maze of books for demonstration purposes. When you turn Pipe Explorer on, it will beep twice and then start driving through the course. When it hits walls, it will reverse, then turn away from the wall and keep going. This next test is with the center switch down. As you can see, the robot is buzzing every time it hits a wall. When Pipe Explorer encounters a blockage, represented here by the books blocking the path, it will stop moving and beep until the far right switch is closed. When you close the switch, Pipe Explorer will stop beeping. You can then move it to a different section of pipe, open the switch again, and Pipe Explorer will keep going.